Section 1.1, second video. Estimate the slope of the tangent line to the curve y is equal to x squared at the point 2,4 using the other given point. Alright, here's my curve y is equal to x squared, or parabola. They're giving us a point 2,4 and they're giving us a point 416 right here. And they want us to estimate the slope of the tangent line to that curve at the point 2,4. So at the point 2,4, the slope of the tangent line, or my tangent line, will look something like that. Well, they want us to estimate that using the other point. So I'm going to calculate actually the slope of the secant line. Remember the secant line is the line that connects those 2 points. So I'm going to say the slope of the secant line now is going to be change in outputs over change in inputs. So 16 minus 4 over 4 minus 2. Well, that gives me 12 over 2. And that'll give me 6. Now what is 6? The slope of the secant line. They want me to estimate the slope of the tangent line. So I'm going to put m tangent is approximately 6. It's not exactly 6, but we're using that secant line to approximate that one. Let's look at B. Part B, we have the same directions here. Let's find the slope of the secant line. That'll be change in outputs, so 6.25 minus 4 over change in inputs, 2.5 minus 2. Well, that gives us 2.25 over 0.5. Well, what's 2.25 over 0.5? That'll give us 9 over 2. Now that's m secant. How about m tangent? M tangent is about 9 over 2. Now notice what we just did. We calculated the slope of this secant line to estimate the slope of my tangent line at the point 2,4. What would my tangent line look like? My tangent line would look something like maybe this right here at that point 2,4. All right, let's look at part C. For part B that we just did, or for the graph in part B, find the equation of the secant line. So I want that equation of this secant line that we actually calculated the slope of. Well, in that last example we did in the last video, how did we calculate the slope of a line? We said y minus y1 is equal to m times x minus x1. So pick one or two points here. Probably 2,4 would be the easier one to use. And we'll have y minus a y coordinate of 4 is equal to m. What was my slope of my secant line? 9/2 times x minus my x coordinate is 2. And we'll go ahead and clean that up. Y minus 4 is equal to 9/2 x minus 9. So y is equal to 9/2 x minus 5. Now what is this? This is the equation of the secant line. Now let's take a look at something here. Over here we calculated the slope of the tangent line at the point 2,4. The slope of the tangent line at the point 2,4, we estimated that to be about 6. Over here for the same curve at the same point, so basically the same tangent line here, we calculated the slope to be 9/2. Well, the actual slope there, which you're going to figure out how to do this later on, is going to be 4. So what is that? That's 4 and 1/2, 9/2. So what is closer to the actual value? The 9/2 or the 6? I would say the 9/2. Doesn't that look like it's closer, the secant line slope to that tangent line slope, than these are? And actually, the closer these 2 points are together on your curve, the more accurate your slope of your secant line is going to be to your slope of your tangent line.